Assalamualaikum and hi everyone. Today our group will present one biological treatment plant which is membrane bioreactor MBS. This group have 4 members which is Nur Shanini, Nur Farisha, Nur Atira and Siti Aisyah. Before I tell you what membrane bioreactor are, let's first know what the biological treatment is. At one biological treatment refers to the use of biological process for the treatment and purification of wastewater or other contaminated water sources. This approach goes beyond the basic biological process used in conventional wastewater treatment and incorporate more advanced technique to achieve higher level of pollutant removal and water quality. So, a membrane bioreactor (MBR) is a process which combines a microfiltration or ultrafiltration membrane unit with a suspended growth bioreactor and is now widely used in both municipal and industrial wastewater treatment plants. So in membrane bioreactor, there are word of bioreactor. So bioreactor is means physically designed chamber to support a biologically active environment, namely where bacteria and protozoa can grow and consume some of the substance within the raw wastewater. So basically, they can be aerobic, anaerobic, or anaerobic, depending on the presence of oxygen and nitrite or their absence. Typically, membrane are installed after aerobic or anaerobic bioreactor. So the next word is membrane. So in wastewater, membrane act as a solid liquid separation device, keeping the biomass within the bioreactor before discharging the treated effluent to the nature. Basically, they take the place of clarifier used in the conventional active sludge process. So both micro and ultrafiltration membrane can be used in MBR application. Typically, UF membrane are the preferred choice because of their superior separation characteristic and lower falling tendency.
Next, we go through the membrane bioreactor components. MBRS have 6 components. First is influent pipeline. Second, pretreatment units which includes screening and grit removal. Third, bioreactor with aeration and possibly anoxic zones. Fourth, membrane module. Fifth, permeate pump. And lastly, effluent pipeline which is to discharge or reuse.
For the operational or process of MBR, actually membrane bioreactors was combination of biological treatment and membrane filtration for efficient wastewater treatment and recycling. Steps of MBR process, they have 5 steps. Okay, first step, wastewater enter the system. Wastewater first goes through a screen to remove large debris and then enters the bioreactor. Next step, biological treatment. In the bioreactor, microorganisms consume and break down the organic pollutant in the wastewater. Next step, membrane filtration. The mixture of water and microorganisms flow through the membrane modules. The membranes filter out impurities, allowing only clean water to pass through. The next step, collecting the clean water. The filtered water, known as permeate, is collected and can be used for various purposes or safely discharged. And the last step, managing the sludge. As a sludge, a byproduct of the microorganism's activity, is removed from the bioreactor to keep the system balanced. So the next slide shows the simulation process of membrane bioreactors.
Next, we move to advantages. First, high quality effluent. MBRS produce high quality treated water due to the use of membrane filtration, which effectively remove suspended solid, bacteria, and pathogen. This makes the effluent suitable for reuse in various applications or for discharge into sensitive environments. Secondly, better biotreatment. The longer solids retention times tend to provide better biotreatment overall. The condition encourage the development of the slower growing microorganism, specifically nitrifiers. MBRS are especially effective at the biological removal of ammonia. While MBR technology is not always the best water waste treatment solution, it can sometimes be more expensive than other solutions. For example, MBRS are increasingly becoming the technology of choice for water and water waste application where high quality treated water is required or space is limited. Last four advantages, small footprint. MBR system often take up less area than a conventional treatment system because they combine biological treatment and membrane filtration in one unit. This compactness is especially useful in urban area or where land availability is restricted. Next, we move to the disadvantages of MBR system. First, high cost. Reactors is that they typically cost more than traditional system, both in terms of initial capital outlay and long-term operation and maintenance costs due to the cost of membrane modules and associated equipment. This initial investment can be significant barrier to adoption, particularly for small-scale application. Secondly, high energy needed. Several factors contribute to MBR system relatively high energy demand. Fine bubble diffusion, which provide dissolved oxygen to heterotrophic bacteria, requires energy-intensive air compression. Pumping slab inside the system demand energy, as does pumping the treated water, heating and pumping or backflush and cleaning chemicals, as well as the operation of process control equipment and instrument, all increase energy expensive. Lastly, membrane fouling. MBR membrane frequently clog owing to membrane fouling. Water waste stream containing free oil, whether vegetable or mineral, might pose a problem for MBR, necessitating pre-treatment with a separate plate separation or dissolved air flotation stage to prevent membrane fouling. However, adding additional stage may raise costs and negate the benefit of MBR tiny footprint.
For conclusion, membrane bioreactors (MBRS) are advanced systems that combine biological treatment with membrane filtration, resulting in highly effective wastewater treatment. They produce high-quality effluent that is suitable for discharge or reuse. The main components for MBRS include pretreatment units, bioreactors, membrane modules, permeate pumps, and sludge handling systems. MBRS offers several advantages such as improved effluent quality, a compact design, and a reduced need for secondary clarification and tertiary treatment. These features make MBRS widely used in both municipal and industrial wastewater treatment for their efficiency and reliability. That's all from us. Thank you for your attention. I hope you found this presentation informative and useful. See you.